Okay students, let us try to solve this question. It is, what is the lowest value of n that allows g orbital to exist? Okay, the question is related to quantum numbers and let us try to solve it. We know that the values of L, if are 0, 1, 2, 3 and 4, then it corresponds to s orbital, p orbital, d orbital, f orbital and g orbital. So knowing this, that L has if value of 0, then it is s orbital. Fine. So similarly here in the question we are given g orbital. So you can see for g orbital the value of L has to be 4. So let us try to write and understand. For g orbital, L will be equal to 4. Now we know that as L value can range from 0 to n minus 1. So if we put here to get the value of 4, then what you will have? To have L is equal to 4, minimum value of n should be what? Just try to understand what should be the minimum value of n here, this one, using this, so that you get the value of L as 4. Obviously it has to be 5 because n 5 minus 1 will be giving you 4. Okay, so therefore your n value will be 5. So that is what was the question. The minimum value or the lowest value of n should be what when g orbitals exist. So if g exists, L will be 4, and to have L4 we should have n as 5. So that is how it is solved. Let us try to solve another question also of the similar type. Now an electron is in one of the 3D orbitals. Then you are asked to find out the possible values of n, L and m. That is principal quantum number n, azimuthal quantum number L and magnetic quantum number n. So this is simple students. Let us see that for 3D orbital we are wishing to find out n value, L value and m value. Now here 3D here indicates 3 is the principal quantum number, the shell. So n in 3D would be your 3. Okay. Now how do we find out L? So values of L are ranging, as I just now told you about, values of L range from 0 to n minus 1. Okay. So value of L here should be range from 0 to n minus 1. N we are here having 3. So if we put 3 minus 1, it would be 2. So values of L would be 0, 1, 2. Okay. Ranging from 0, 1 and 2. But then here the value of the orbital which we need to find out is, the orbital given to us is 3D. So now we are aware for that. I just now told you that if L is 0, 1, 2, 3, 4, then the orbitals which correspond to them are S, P, D, F, G. So here it is D. So value of L has to be 2 among 0, 1 and 2. Hence the value of here L has to be 2. Because you are given 3D and value of L is 2 for D orbital. And here 3 is the principal quantum number. D we are writing value when you are having D orbital, we are writing when L is equal to 2. Fine. Now the value of L can be found out with the help of azimuthal quantum number. ML you are having is the magnetic quantum number. You know that value of it ranges from minus L to plus L. Okay. So if L is 2, then values of M would be minus 2, minus 1, 0, plus 1 and plus 2. So these are the values. So that is what was the question. You were supposed to find out the possible values of n, L and m. So for 3D orbital, value of n is 3, value of L is 2 and value of M are these 5 values you are having. So just have a glance. The important point in this particular question was you need to know when the values of L is 0, 1, 2, 3, 4, corresponding orbitals for it are S, P, D and F. Okay, I hope it is understood. Thank you all.